Hello grade 12, welcome to my channel, and let us have a look at this question. It came out of the first term maths exam from KZN. Okay, so we will just go through it nicely. And just of note, as I skimmed this diagram has been repeated from last year's exam, the same exam, the term 1 exam. So this is the same diagram, but of course the set of questions will slightly differ. So this is just to emphasize, guys, you need to practice these things as often as you can, okay? Because it's very important. Sometimes during the term exams, a lot of repetition occurs. The only difference is the final exam. It's always new questions, okay? Anyway, let's have a look at this. So we have discussed trig functions and identities. So all of these things come together in this question. So you need to be able to handle them well. Okay, first question, we need the general solution of those of this equation, okay? Anyway, so 6.1, we have cos of x minus 45 degrees equals sine 2x, okay? Now from the lessons that we had, we could see that we could actually remodel this as some cos beta equals sine x. Because when everything is in terms of the cos and sine, but the angles are different, okay? So what we can do, we change the other one into a cos. So we can say cos beta is equal to the cos of 90 degrees minus x, because cofunctions are sisters. Because now once we have cos, it means this angle must be the same as that angle, and so we can drop the trig ratios. So this is the technique. So a very careless student, or one who doesn't attend classes, because I've been giving classes on these, a student who doesn't attend classes would want to expand here and run into problems, okay? So be very careful. So this implies that cos of x minus 45 degrees is equal to, the cofunction here must have been 90 degrees minus 2x. Okay, now that everything is in terms of cos, it means those two angles are the same. So we can say x minus 45 degrees is equal to plus or minus, keep this one in brackets, okay, plus k times 360 degrees, where k is an element of integers. Is it done? No, we need to isolate x. So this implies, now we do x minus 45 degrees equals, now when we take the positive one, it just remains 90 degrees minus 2x plus k 360 degrees, or we say x minus 45 degrees equals, now the negative is going to give us minus 90 degrees plus 2x plus k 360 degrees, where k, I don't know guys, I just write bad, is an element of integers, okay? So this is literally what happens. So this is why to keep these brackets is very important. Now we just transpose the 3 to the other, the 2x to the other side. It becomes 3x equals, we bring in 45, 90 minus 45 is just 45 degrees, plus k times 360 degrees, or we bring in the x, we get minus 2x plus x, we get minus x, equals, we move 45, minus 90 plus 45, it's going to be minus 45 degrees, plus k 360 degrees, where k is an element of integers, okay? So now we don't want minus x, we don't want 3x. So we divide by 3. We get x is equal to 45 divided by 3. That's 15 degrees plus k times here is going to be 120 degrees. All right. Oh no, I made a mistake, guys. Remember, this is 90 plus 45. So this is going to be 135. Sorry. And when we divide that by 3, we get 45. Okay, almost made a blunder. Or we just multiply by negative. This is 45 degrees minus k times 360 degrees, where k is an element of integers. So now these are the general solutions. Can you see? When you have the strategy, you know what to do. So how do we score marks? When we use correlations, that's a mark. Okay, and there's 2 solutions. Those are each going to get a mark. Now the extra mark is using the cosine stuff. Okay, so that is 4 marks. Nice and easy. Okay, let's do 6.2. 6.2, we are told in the diagram the graphs of f of x equals sine 2x. Okay, so this one is labeled again, so this is easy, we can see it. But we would also know that this graph is now completing a full period in 180 degrees, which is half the period, because of the coefficient of the angle 2 there. Alright, so we know that that should be the sine graph, so not a problem. So anyway, very important, what is this maximum right here? This maximum right here, what should it be? Alright, so we will know that technically this should be at 45 degrees, right? Because if this is 2x, it means everything is going to occur at half the angle. Normally we get it at 90, half of 90 becomes 45, okay? So that's what happens. Alright, okay, alright, not a problem. So that's what we know. You can see that there's a label there. Okay, we will read on. So the period is 180, and we're getting that first maximum from 0 at 45 degrees. And it seems to coincide with the cosine one. But let's read on. And g of x equals cos of x minus 45 degrees are drawn in this interval minus 180 to 180. A is the minimum point of the graph of g. So this means down to A, we are at a minimum. So when are we going to have a minimum? We look at this function of g. We see this is shifted 45 degrees to the right. Now we were supposed to have this at minus 180 right there. But now this is going to shift 45 degrees to the right. And how do we do that? We just add 45 to minus 180. So it gives us minus 135 degrees. Nice and easy. Okay, so we know the coordinates of A. Of course, the minimum is at 1. So the coordinates of A is going to be minus 135 and essentially 1, because that should go to minus 1. Oops, that's so slurred. They have the same minimum. So this should be at minus 1. Okay, and that should be at 1. Okay guys, know these things, because I have shown you how to work on these graphs. So if you took those lessons for granted, you will die a slow death, but then that's your choice, isn't it? Yes, you are choosing to die. Okay, C is a maximum point. We can see there, it's already worked out nicely of both graphs, or sorry, on both graphs. Okay, the two graphs intersect at B, C, and D. And we can see there that there's a point of intersection there and there. But if we know the coordinates of B, we should be able to know those of D because of symmetry for the cosine function. Easy. Okay, and of course our general solutions are going to help us to do that. Nice and easy. All right, so let's just answer those questions nicely. So we have 6.2.1. We're told to write down the period of G. Now G of x, the coefficient of the angle is 1, so it remains the original 360 degrees. 6.2.2, we've got A. We need to write down the coordinates of A, so we already worked them out. So A is minus 135 degrees and minus 1. Okay. B, so that's the point of intersection. So we can see this is on the negative side. Of course, this is the fourth quadrant. Can you see from 0 to minus 90? This is more like 0 to 270. So this is within that first or that fourth quadrant. So this is on the fourth quadrant. So we expect a negative acute angle here. Now let's look. If we say K is 0 in both instances, we get 45 and 45. So this is spelling out this one. So that's not what we're interested in. So when K is 0, we get that C. Then let's say K is 1. When K is 1, what happens? This is going to be 45 plus 120. And that gives us 165. Okay? So where is 165? This is in the second quadrant, and we can see from 90 to 180, that's the second quadrant. So this seems to be spelling out this coordinate right there. So this must be 165. Okay. Of course, there's a trick we can do here. Once we get 1, we may not need the general solutions. We can just simply say from 180, what acute angle did we subtract to get to 165? I think it's 15 degrees. So 180 minus 15 gives us 165. Now that same small measure is the one that we're going to add to 90, because we are just going to add to 90 here to move back into the fourth quadrant from 270. So this is going to be minus 90 plus 15. It gives us 75. So this should be 75. So there are many ways. You can still use the general solutions to get this angle. So this is minus 75 degrees. Great. So now we know what should the y coordinate be, because now we also need it. So the y coordinate, it looks like it's going to be negative a half. Of course, we can check it. We take this minus 75, we plug it there. It's going to be minus 75 minus 45. So we just simply say cos of minus 75 minus 45. This gives us minus a half indeed. So we know that that value is good. So we can go B is minus 75 degrees and minus a half. One can easily write that as a decimal and say minus 0.5. The other way, we can use the general solutions and say K is minus 1. So 45 minus 120 is minus 75. So it still gives us. So there are many tricks, honestly, guys. I can no longer try to exhaust any of them. You need to know them. So this is good. 2 marks for the pairs. All right. Great. So let's go on. 6.2.3. We are told to use the graph to determine the values of x in this interval, which is the first 2 quadrants from here to there, where f of x divided by g of x is less than 0. So what does this mean? We know that this simply represents y values of the function f, here y values of g. Okay, So when can we see such a thing? It's when we have a situation like this. When can this be less than 0? It's when this one is negative and this one is positive, or vice versa. Okay, we can switch the positions. So we are looking for a situation where f is negative, but g must be, for the same x value, must be negative. Or when f of x is positive and for the same x coordinate, the y value must be negative for the g, because that's when we're going to get a negative answer. Now we've been given the place to look, but now we start looking. The y values here are positive and they are positive. So positive divided by positive is positive. So this is out, and they're still positive here and positive there. Again, a positive and a positive is out. But if we look at this interval, so if we focus on this interval between these two lines, we will see that we have an x-intercept here, which we don't know. But within this interval, the graph of g is positive and the graph of f is negative. Okay? And we can see that a negative divided by a positive is definitely going to satisfy our constraint. So this means this is the interval that answers the question. Okay? So that interval answers the question. I don't know why it looks strange. Okay? So that's the interval we want. And of course, after this, they are both negative. So negative divided by negative is positive, and the same story occurs. So that is just that interval. Now we need to know, what is that x-intercept? So we know that the graph of f was the graph of g, because this is the graph of g. G is a cosine function, so it's supposed to have an x-intercept at 90 degrees, but this is going to delay 45 degrees later. So 90 plus 45 lands us at 135. So that is 135 degrees. So now we have our interval. So we know that x must be less than 135, greater than 90 degrees. For just a moment. Okay guys, so that is the interval. But now why are we not including 135? Because g is 0 and g is on the denominator. A division by 0 is undefined, okay? That's why we're not including 135. But why 90 is also not included? Because remember, f is 0. So this would essentially give us 0. But can you see the inequality is not less than and equal to? So those need to be excluded. So we get our 2 marks and we smile. Okay? Usually the notation itself entirely is 2 marks, but one can argue about the inequalities as well as that 135 because you had to work it out. Okay? So let's see 6.2.4. Now, it says solve for x in this interval. If this is the case, okay? Now it says show all the workings. Okay, now this is one of those higher grade questions, but it's nothing out of the ordinary. A student who does maths must know. So we need to solve the inequality basically. So we have sine 2x greater than 1 over square root 2 into cos x plus sine x. So now what is the trick here? This is to suggest that, look, this is the f function. So we need to show that this is the g function. Okay, so we need to simplify. So this is sine 2x greater than or equal to, we distribute. But now as a math student, you need to know how to distribute well. So this is going to be cos x strategically times 1 over square root 2 plus strategically root 2 sine x. Okay, now you should understand what I'm doing. If you don't, you are in trouble. So this is cos x. Now I want this to be the cosine compound angle, because I have a cosine compound angle identity right there. So this is as good as cos 45 degrees plus, now this is as good as sine 45 degrees. Oh, don't know why my hand is shaking, but it's because I'm hungry. Times sine x. Okay, now we can see that identity nice and easy. Now this is as good as cos of the first angle minus the second angle. Now isn't it g of x? This is good. So therefore we are saying here f of x is greater than or equal to g of x. Again, we are given the domain in which to look for this. Now we're looking from the first quadrant to the second quadrant in the anti-clockwise direction. Okay. So what are we going to say? We want a situation where the graph of g is either above, the graph of f is either above or they are equal. And we can see that technically the graph of g is essentially above here, right? Whereas the graph of, okay, let's choose another color. You can see that in that interval from this 165, as much as it was not asked, but we can see it, they are equal at 165 degrees. But then the graph of f is above the graph of g up until we get to 180. So this is the interval that we're looking for. Okay, so this is the interval. It satisfies the inequality. Is there anywhere else? No, there is nowhere else, because we will see that from here backward, the graph of g is above the graph of f up until they are equal at c. And again, all the way back to 0, the graph of g is above the graph of f. So those intervals are not important. So this therefore tells us that x must be less than or equal to 180 degrees, but greater than or equal to 165 degrees. Okay, why are we including? Because they are equal at 165, but at 180 included, the graph satisfies the inequality. So these values are both included. So this is a very nice question. It's one question to look out for in the June exams, trial exams, and the final exams. So I hope you guys enjoyed that video there. Now let's see, how do we score marks? Obviously, when we use special angles in that strategic way, we get our first 2 marks. When we contract this expanded identity for cos, then we get a mark. The interpretation is not important, but the answer here is 2 marks because we needed that 165. Okay, so this is how we score those 5 marks here for a total of 16 marks. Alright guys, so I hope now you can see the light. If not, then I don't know what can help you guys. So there's no better analysis than what we have done here. And of course, if you need a more detailed and chilled approach to this, watch the lessons I have done for you guys. And of course, I would advise that you attend the classes, because in the classes we demystify a lot of misconceptions, and of course we try to work at things in a strategic way, so that when you see these in practice, it becomes much easier and you can score your marks effortlessly. Those of you who wrote this paper must have seen that I have done this. First of all, the diagram is a repeat from last year's diagram for term 1 exams. So it's not a foreign diagram to begin with. So anyone who practiced this would have flown past these questions. Of course, the questions will be modified or slightly different, but the fact that the diagram is the same functions, it means you would understand the dynamics well. I have taught this in our trigonometric function lesson. So this was easy. So you must have breezed through this question. And if we look back, we've done reduction formulae, simplification of expressions, we've done general solutions, we've done the terminal arms, easy stuff. And look, exponential equations, we've done parabola, inverse functions, done parabola in the straight line, we've done. This came from the EC. As you can see, when I skimmed here, I saw that not necessarily the same question, but the idea. EC trial 2022. It was like this, and one had to show it like this. Okay, so if you paid attention to those videos, you cruised. Look at this one again. This was from February, March 2018. A similar question. Of course, it's slightly different here, but it's a similar question. So you can clearly see, if you've been practicing these and you watched my videos, you should have been fine. Now this one is an interesting question. Okay, it's an interesting question. It needs a lot of logic, but it's a very easy question, but lots of logic. Can you see these ones? The first two are repeated, so you just ignore them. You keep them as they are. But from here on, can you see it's a 7? It alternates with a number. 7 alternates with a number. 7 alternates with a number. Therefore, it means this sequence will carry on like that, alternating between 7 and those numbers. And if you check from 12 to 17, what did we add? 5. 17 to 22, we added 5. So this is an arithmetic sequence against this repeating sequence, so to speak. So it's not that difficult to figure out what you're supposed to do there, so you'll get an idea. So we will work through these questions. I've shown you how to use the SN to find the terms like this. These are things I gave lessons on sequences and series. So essentially, guys, if you have been really a good fanatic alongside me in my channel and essentially attending the classes I've been giving and watching most of the videos I have produced so far, this was a distinction, a total, to be honest. Perhaps time could have been your enemy in case you kind of panicked somewhere, because obviously when you practice these, you don't automatically expect some of them. But I can tell you, whatever you practice, guys, be anticipating it. The fact that you got a chance to practice it, it means it stands a very good chance of coming. God would never direct you into something and yet it's not going to be beneficial. Okay, so anyway, guys, we will discuss this paper still entirely so that I can leave you guys ready to cross over to term 2 work. But I just was intrigued by this question, first by seeing the repeated diagram, secondly the nice questions that came on it. Anyway, guys, I hope you're gonna leave a thumbs up. I'll see you some other time. Goodbye.